So the question is that if a wave y equal to a sine kx minus omega t is incident on a rigid boundary and gets reflected, then what will be the equation of the reflected wave? Now let's take this as a rigid boundary as shown in the figure. This y-axis, this is the rigid boundary, and a sine omega t, no sorry, a sine kx minus omega t. So I'll draw the wave at time t equal to 0. See, this is the wave at time t equal to 0. See, actually in the right side of so along the x-axis, rather in the right side of the x-axis, the wave cannot exist in reality, but mathematically it exists. So at t equal to 0, so the incident wave has equation how much? Y equal to a sine kx, and that is what it is drawn, a sine kx. This in the right part I have shown it by a dotted curve because it does not exist in the right side. Now what will be the equation of the reflected wave? Now here, as we know that if this is a rigid support, this is a rigid support, and if you have the incident wave in this direction, so if you have the incident wave in this wave, so the reflected wave will be like this, right? So the incident wave traveling towards right and the reflected wave will travel towards the left, because this point should be the, this point actually, this point should be what? This point should be the node. Yes. So for this to be a node, this type of destructive interference is necessary. So let us go back to the sine curve. So this was the incident wave, the dotted non-existent part, and this is the existent part. So this is the incident wave. And what about the reflected wave? Actually the reflected wave should be like this. Else how will they interfere destructively at the node, right? Because of this condition, we want this condition to happen. When this goes this way, then there comes the reflected wave. So see here, from this line, horizontal line, this down, this value is equal to this value, so they will superpose to give 0 displacement at this point, 0 displacement at the node. So let us look back at it again. So this white one is the incident wave, sorry, not the incident wave, the incident wave was that, the green one. This is the reflected wave. So here the reflected wave, therefore the reflected wave has equation a sine kx itself at time t equal to 0, and it is moving towards negative direction of x-axis. Therefore the equation of the reflected wave will be a sine k, and in place of x you have to write x plus vt. If it moves towards the left with a speed v, then it is function of x plus vt. So that is a sine kx plus omega t.